855, Law of Sines, Part 1. This tells us that trig functions can be used to solve triangles with no right angles. So, for instance, if we're given two of the angles, we can find the missing angle by using that triangle is 180 degrees. We subtract the other two angles, and whatever the leftover degree is that missing angle. From there, we can use law of sines in order to find the missing side that we're looking for. If we look, let's just look at one of the examples. So, this is your law of sines. So, if you have the sine A, or the sine of the angle A, over this opposite side length, which is side length A, is going to be equal to the sine of angle B over the side length that's opposite the angle B, which is the side length B, and so on. So what does this all mean? If we look at this example, it tells that a satellite is orbiting the Earth, passes directly overhead at an observation station in Phoenix and Los Angeles, 340 miles apart. So when we do this, we're going to draw ourselves a picture. If this is Los Angeles, this is Phoenix, they are 340 miles apart. It has a satellite that's orbiting, so that's going to be right above it. So we're going to have this triangle here. I'm going to let's label Los Angeles A, Phoenix B, and the satellite C, which means this angle here is angle A. The side length across from it is the side length A. This angle here is angle B. The side length across from that is side B. And this angle here, angle C, the side length across from that is the side length C. It tells us that at an instant, when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix. So Phoenix at angle B is 60 degrees. And then angle A, which would be Los Angeles, would be 75 degrees. From here, we are finding out how far the satellite is from Los Angeles. So we want the distance from Los Angeles to the satellite, which is this distance here. So we're finding for B. We're going to be using the 60 degrees for the angle B. So we're going to take the sine of angle B over side length B and use the side length that we have, which is the 340, with the opposite angle measurement. So that would be sine C over 340. Now, we have to find for the angle measurement C. So we're going to take 180 and subtract the two side lengths that we have. So that's 75 and 60. The 75 plus 60 gives us 135. So that's 80 minus 135, which gives us 45 degrees. So angle C is 45 degrees. We're going to plug all of these values in and simplify. So we're just going to do the sine of angle B, which is 60, over side length B, is equal to sine C, which is 45 degrees, over 340. We are going to cross multiply, and this is going to give us B times sine 45 is equal to 340 times sine 60. We're going to divide each side by that sine 45. These cancel, so we're going to use our calculator to find what B is. We're going to have 340 sine 60 divided by sine 45, which gives us 416.413, so on. We're rounding to the nearest whole number here, so that's just 416 miles. For our next example, we're looking at finding the length here for AC. AC is going to be side length B in this case. So we need the degree for side length B as well as the degree for side length C, since we have the opposite, the angle measurement for angle C, since we have the side length opposite of that. So use your 180 minus the two side lengths that we have, so 118 plus 22. The 118 plus 22 gives us 140. So we're doing 180 minus 140, which gives us 40 degrees for angle C. So from here, we're going to take the sine of angle C over the side length C, which is 24, and set it equal to the sine of angle B, which is 22. I'm going to put that in after, over its side length, which is what we're finding. So sine 40 over 24 is equal to sine 22 over B. Cross multiply. You have B times sine 40 is equal to 24 sine 22. We're going to divide each side by the sine 40. These cancel, and we have that B is equal to, use your calculator, 24 sine 22, close those parentheses, divided by sine 40, and that gives us 13.98. We're rounding to the nearest whole number here, so that's 14. For example B, we're finding the side length AB. So that side length AB is actually side length C because it's opposite angle C. We also have the side length that's 7, which is opposite angle B, so that's side length B. We have angle B, we have angle C, so we do not need to find the missing angle that we have here. So we can just set up sine angle C over side length C is equal to sine angle B over side length B. Plug in your values. The angle C is 53 degrees over the side length C, which we're finding. Sine B, the angle B is 44, so that's sine 44 degrees over B, which is 7. Cross multiply. We have C sine 44 is equal to 7 sine 53. We're going to divide each side by the sine 44. Cancel out, and C is going to equal, use your calculator, 7 sine 53, close your parentheses, divided by sine 44, close those parentheses. You get 8.04, so on. We're rounding to the nearest whole number, so that's going to be 8. For our next example, we're finding the side length BC, which is the side length A, since it's opposite angle A. We have angle C, so we need to find side length C in order to do this, but we don't have that, so we are going to use angle B because we have the side length B. So find angle B by doing that 180 minus the two angles that you have added together. So 58 plus 93 gives us 151. 180 minus 151 gives us 29 degrees for angle B. So from here, we're going to use the angle A and side length A. So sine angle A over side length A is equal to the sine of angle B over side length B. So plug in your values. Angle A is 93 degrees over side length A, which is what we're finding. Angle B is 29 degrees over side length B, which is 16. We're going to cross multiply here, so we have A sine 29 is equal to 16 sine 93. Divide each side by the sine 29. Use your calculator. So 16 sine 93 divided by sine 29 gives us 32.957, so on. So that's going to be 33. For our next example, we're given the measurement for angle B, which is 117 degrees, the side length of angle A, which is 16, and the side length side length B is 38. So we're dealing with angle B, side length B, and side length A, which means we also have to deal with angle A. So we're going to be doing the sine of angle B over side length B is equal to the sine of angle A over side length A. So this is going to be rewritten as sine 117 over 38 is equal to sine A over side length A, which is 16. We're going to cross multiply. So this is going to give us 38 sine A is equal to 16 sine 117. We're going to divide each side by the 38. And we have sine A is equal to 16 sine 117 over 38. So from here, in order to get angle A, because sine A is not angle A, we are going to do the inverse of sine, which is that sine to the power of -1 on your calculator, times 16 sine 117 over 38. So using your calculator, you want to hit that second button, then that sine button, 16, your regular sine button, 117, close the parentheses, 117, close the parentheses, then divide by 38, close that whole parentheses, and we get that angle A is 22 degrees. And we're going to be giving these as whole numbers. So we're going to round to the nearest whole number. So if we look at our last example, we have that the angle measurement for angle C is 145 degrees. Side length B is 7, and side length C is 33. So we're going to be working with sine C over C is equal to sine B over B. Plug our values in. We have sine 145 over 33 is equal to sine B over 7. Cross multiply. We have 33 sine B is equal to 7 sine 145. We'll divide each side by the 33. Then we get sine B is equal to 7 sine 145 over 33. So we're going to do B, or angle B, is equal to the inverse, so sine to that -1, of 7 sine 145 over 33. We use our calculator for this. So we're going to hit that second sine button. We have 7, regular sine 145, close the parentheses, divided by 33, close your parentheses again, and we get 6.98, so on. So angle B is 7 degrees.